Hello students, so welcome to today's class. Today we will be doing Ionic equilibrium question part 5. Disclaimer, the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the images. In this session, we will be practicing question from 35 to 42. Question says that what would be the pH of a solution obtained by mixing 5 gram of acetic acid and 7.5 gram of sodium acetate and making the volume equals to 500 milliliter. The K of the solution, the K of the acid is given as 1.575 into 10 to the power minus 5 and pK is 4.76. Options are A, pH is equals to 4.70, B, pH is less than 4.70, option C, pH of solution will be equal to pH of acetic acid, and D, pH is greater than 4.76 and less than 5.0. Your time to solve this question starts now. The time is up for this question. So what was being asked in this question? So we are being asked the pH and what solution we are taking. We are taking 5 gram of acetic acid and 7.5 gram of sodium acetate. The volume which I am taking is 500 ml. Now pK value and Ka value is also given and you have to now find the pH. The correct answer is D, that your pH will be greater than 4.76 and less than 5.0. How will solve it? So we know that concentration is equals to mass into 1000 by molar mass into volume. So it is typically number of moles per unit volume. So to keep the volume in liters, we have multiplied this thing by 1000, right? Okay. So what is the concentration of the acetic acid? So we have taken 5 gram of acetic acid. So number of moles will be given mass by molar mass. And since the volume is going to 500 milliliter, so 500 by 1000, or we can write it into 1000 by 500. So if you calculate this value, you will get 0.166 molar as the concentration of the acetic acid. Similarly, we can calculate the concentration of the sodium acetate by putting the mass of sodium acetate divided by the molar mass of sodium acetate, and that thing is divided by the volume of the solution in liter. So since volume is given in milliliter, again we are dividing this 500 by 1000, or we are multiplying it by 1000 by 500 to give us 0.183 molar. So we got the concentration of the salt, we got the concentration of the acid. Now how we'll calculate the buffer? So how this salt would have been formed? So it would be reaction of the sodium hydroxide. So we have taken one possibility, and the reaction of acetic acid. So that would give us sodium acetate and water. Now to calculate pH, we will simply use this formula, which is pH is equals to pKa plus log salt by acid. Here salt is your sodium acetate and acid is your acetic acid. If you put the formula with the values, that is 4.76, 0.183, we have calculated it, and 0.166, and this thing also we have calculated. Your calculation will give you 4.76 plus log 1.10. Further on calculating, you will get the pH as 4.80. So we can say it very clearly that this pH is greater than 4.76 and less than 5.0. So we have simply used the acidic buffer formula, which is Henselbach equation, and calculated the pH. Next question. The pKa of a weak acid is 4.5. The pOH of aqueous buffered solution of HA in which 50% of the acid is ionized is, options are A 4.5, B 2.5, C 9.5, and D 7.0. Your time to solve this question starts now. The time is up for this question. So what was being given? So we are being given the value of pKa, which is 4.5, and we have to calculate the pOH, given that the HA is 50% ionized. Okay, it is the acid which is 50% ionized. Clear? Okay. So the correct answer is C, 9.5. So from the aqueous buffered solution of HA, 50% HA is ionized. That means we have the concentration of A minus S. How much? The concentration of HA. Clear? Okay. Now if I talk about the buffered solution of a weak acid, then it is a acidic buffer. So what will be the pH? pH will be pKa plus log A minus by HA. Right? So the concentration of A minus is equals to HA because it is 50% ionized. We have calculated it earlier. Because half of this is dissociated. So what else will be the concentration of HA? That would be the concentration of A minus as well. So this and this thing get cancelled out, and we can write this thing as log 1. So pH is basically equals to pKa plus log 1. Now log 1 value is 0, therefore pH is equals to pKa, that is 4.5. Okay, this thing is given here. So we got the pH. How we'll calculate pOH? So simply we will calculate it by subtracting the value of pH from pKw. So pKw value is 14. So 14 minus 4.5 will give you 9.5. So therefore your pOH is 9.5. That is option number C. Next question. An aqueous solution of 1 molar NaCl and 1 molar HCl is. Options are A, not a buffer, but pH is less than 7. B, not a buffer, but pH is greater than 7. A buffer with a pH that is less than 7. A buffer whose pH is greater than 7. So we are given an aqueous solution of 1 molar NaCl, which is a salt of strong acid and strong base, and a strong acid whose concentration is 1 molar. Right? So we are given an aqueous solution of these two things. So its pH will be, of course, less than 7, but it will not act as a buffer. So what we know is that NaCl is a salt of strong acid and strong base. So for a solution to act as a buffer, the salt should be of a weak acid and strong base, or weak base strong acid, or weak acid weak base. So these three conditions are possible, but it is having a salt of strong acid and strong base, so it cannot act as a buffer. So this thing is itself a neutral solution, right? So the pH decrease is coming out of this strong acid, which is 1 molar HCl. So its pH will be always less than 7. Next question. Question says that direction, first of all, direction is given. In the following question, assertion followed reason is given. Choose the correct answer out of the following choices. And assertion is, when HCl gas passed through saturated solution of sodium chloride, a solid sodium chloride separates out from the solution. Reason is that HCl decreases the solubility product of NaCl. Options are A, both assertion and reason are true, and reason is the correct explanation of the assertion. B, both reason and assertion are true, but reason is not the correct explanation of assertion. Option C, assertion is true, but reason is false. Option D, assertion and reason both are wrong. So your time to solve this question starts now. The time is up for this question. So what was being said? So we are given an statement and the reason is given. Now you have to predict whether the assertion and reason are correct or not, and then you have to also predict that your reason is correct for the given statement or not. So the statement is given as, that if you are passing an HCl gas through a saturated solution of NaCl, means the maximum solubility is being attained in the solution. So that solution we call it as the saturated solution. Through that we are passing this HCl gas. Now an observation is observed that your NaCl separates out from the solution. So first you have to say that this statement is right or wrong. The second thing, the reason is given that if you are passing HCl, then HCl is decreasing the solubility product of NaCl. Okay. So for that reason, we are seeing this separation out of the solution of this NaCl solid. Now you have to say that whether this reason is correct and whether it is the correct explanation of the assertion or not. So answer is that both assertion and reason are true, but reason is not the correct explanation of this assertion. So why the ionization of NaCl is suppressed? It is due to the common ion effect, right? So this thing is due to the common ion effect, which results in the precipitation of NaCl. So this is the reason for that. HCl is of course decreasing the solubility product, but it is not the reason for the crystalling out of this NaCl. Okay, so that's why your correct option is B. Next question. Direction in the following question, assertion followed reason is given. You have to choose the correct answer out of the following. So you are given two statements. First is the assertion, second is the reason. You have to tell that whether these two statements are right or wrong, and you have to also identify that the reason that is given is truly explainable for the assertion or not. So what is the option? So first of all, what is the assertion? The addition of Ag plus ions to a mixture of aqueous solution of NaCl and NaBr causes precipitation of AgBr instead of AgCl. Reason is solubility product of AgCl is less than that of AgBr. Options are A, both assertion and reason are true, and reason is the correct explanation of the assertion. Option number B, both reason and assertion are true, but reason is not the correct explanation of assertion. Option number C, assertion is true but reason is false. Option number D, assertion and reason both are wrong. Your time to solve this question starts now. The time is up for this question. So what is the direction? So direction, we have to say that whether the assertion and reason is true and reason is not the correct explanation or the correct explanation of assertion. So the assertion is given as, so we are adding Ag plus ion to a mixture of aqueous solution of NaCl and NaBr. Okay, and this caused the precipitation of AgBr instead of AgCl. So both can be precipitated. Both are not that much soluble in water. So upon addition of Ag plus, both of these should be precipitated. But it is found that only AgBr is precipitated. You have to find the reason. So the given reason is that the solubility product of AgCl is less than AgBr. Okay. So the answer is that answer is true, but reason is false. So the value of solubility product of AgCl is greater than that of AgBr. Okay. So AgCl is greater than that of AgBr, and therefore it is not precipitating out. So of course your AgBr will precipitate out first before the AgCl, and the reason is that the solubility product is greater, means the product of solubility is greater. Then and then only more will be solubility, and more will be the possibility of addition of this Ag plus into solution without precipitation of AgCl. Clear? So your correct answer is C. Next question. Direction. In the following question, assertion followed by reason is given. Choose the correct answer out of the following choices. Assertion is the ionization of hydrogen sulfide in water is slow in the presence of hydrochloric acid. Reason is what? Hydrogen sulfide is a weak acid. Options are A, both assertion and reason are true, and reason is the correct explanation of assertion. B, both assertion and reason are true, but reason is not the correct explanation of assertion. Option number C, assertion is true, but reason is false. Option number D, assertion and reason both are wrong. Your time to solve this question starts now. The time is up for this question. So we are given a direction, and the direction is saying that you are given two statements. One is the statement and one is the explanation. You have to say that whether the explanation is true or not, and you have to also predict that the reason given for the explanation is true or not. Assertion, that means your statement says that the ionization of hydrogen sulfide in water is low in the presence of HCl gas or the HCl acid. So whenever there is HCl and H2S both in one solution, then it is being observed, according to the statement, it is said that it is being observed that hydrogen sulfide do not dissociate that much. And the reason is given that your hydrogen sulfide is a weak acid. So your reason and assertion both are true, but reason is not the correct explanation of assertion. So we know that HCl gives the common ion H+. So due to the common ion effect, we will see that the H2S dissociation is suppressed. Of course, sir, hydrogen sulfide is a weak acid, but this is not the explanation for the above statement, right? So what is the correct reason? The reason is the common ion effect that is being done by our HCl H+ ion. Clear? Okay. Next question. In the following questions, assertion followed by reason is given. Choose the correct answer out of the following choices. Assertion is A. According to the principle of common ion effect, the solubility of HgI2 is expected to be less in aqueous solution of Ki than in water. Reason is R. Iodide ion I- is highly polarizable. Options are A. Both reason and assertion are true, and reason is the correct explanation of assertion. Option number B. Both reason and assertion are true, but reason is not the correct explanation of assertion. Option C. Assertion is true, but reason is false. Option D. Assertion and reason both are wrong. So your time to solve this question starts now. The time is up for this question. So we are given a statement and we have to say that the reason that is given is either the explanation or not. The statement is that if the common ion effect principle says that the solubility of your HgI2 is expected to be less in aqueous solution of Ki. Okay, so if you take the simple water, the solubility of HgI2 will be more as compared to the solution which is containing this Ki. And the HgI2 is soluble in an aqueous solution of Ki to form a clear solution. Okay, so but they form a clear solution in the Ki solution. Okay, so this HgI2, it dissolves in an aqueous solution of Ki and it forms a clear solution. The reason is that iodide ion is more polarizable. Answer is option number B, that both your assertion, that means statement, and the reason is correct, but the reason is not the correct explanation of assertion. So of course your HgI2 combines with Ki to form the complex which is K2HgI4, and due to this we get the clear solution. Okay, but this is not the correct explanation that your I- is highly polarizable, but this statement is of course true. Why it is true? Because I- is of a large size. Okay, due to this large size, it can be easily polarized as the charge is to volume ratio is very small. Clear? So for that reason, it can be easily polarized. So it is highly polarizable. Next question, direction. In the following questions, assertion followed by reason is given. Choose the correct answer out of the following choices. Assertion are A. A solution mix containing a mixture of acetic acid and sodium acetate maintains a constant pH on addition of small amounts of acids or alkali. Reason is a solution containing a mixture of acetic acid and sodium acetate acts as a buffer solution around pH 4.75. Your options are A. Both assertion and reason are true, and reason is the correct explanation of assertion. B. Both assertion and reason are true, but reason is not the correct explanation of assertion. Option number C. Assertion is true, but reason is false. And option number D. Assertion and reason both are wrong. Your time to solve this question starts now. The time is up for this question. So we are given a statement and we have to say that the statement is correct or not, and then we have to predict the given reason is the correct explanation of the statement or not, right? So the statement is saying that we are taking a solution that is having a mixture of acetic acid and the sodium acetate, and this thing is maintaining a pH constant value of pH on addition of small amount of acid or base. Now the reason is that a solution containing a mixture of acetic acid and sodium acetate acts as a buffer. So this is the reason that is being given, and it acts as a buffer around pH 4.75. The correct answer is option number A, that your assertion and reason both are true, and reason is the correct explanation of assertion. So if you are taking a weak acid and its salt, then this thing is acting as a buffer. So your weak acid is acetic acid and your salt is the sodium acetate, and it is acting as a buffer, and it is maintaining a pH of 4.75. But this thing is for addition of small amount of acid or alkali, right? So if you add a very strong acid HCl and in a large amount, then it will of course change the pH. So it will be only operationable when your pH disturbance is caused by a small amount of acid or base. For that reason, your correct answer is option number A, that your reason and assertion both are true, and reason is the correct explanation for the given assertion. Thank you. This was all for today's session. Hope you enjoyed this. Okay.